Okay, I'm going to be going over problem number 3, which is arguably the toughest one on the exam. And we're not allowed to use a calculator for this one. Number 3 says, a company designs spinning toys using the family of functions given right here, where C is a positive constant. The figure above shows the region in the first quadrant, bounded by the x-axis and this graph of this function for some random value of C. Each spinning toy is in the shape of a solid generated when such a region is revolved about the x-axis. Both x and y are measured in inches. So just so you can get a visual as to what's going on, this region right here is revolved around the x-axis, and I'm not going to make it come down that much because I don't want it to cut into my equation, but it's a solid, and it's revolving around, and it's a spinning toy. Part A. I would guess that part A is worth 4 of your 9 points. Part A says find the area of the region in the first quadrant bounded by the x-axis and this graph. So I'm trying to find this area right here. You're not allowed to use a highlighter on your exam. I'm just trying to point this out to you. We're looking for this area. Well, I know to find the area of any solid here, I'll do part A up here. I know that the area is integrate the top minus the bottom. That's how we do it. So if I'm looking to find the area, I'm going to integrate the top, which is this equation. Okay, and in part A, it tells me that C is 6. So I'm just going to go into this equation and I'm going to put in 6 for C. So 6x square root of 4 minus x squared minus the bottom. Well, the bottom is 0, so I don't need to put in minus 0. So I can just put dx at the end. I do need bounds, though. This is starting at 0, and I don't know where this is ending, so I need to do some work to see where this is ending. My lower bound is 0. My upper bound, I need to see where this graph touches the x-axis. So I need to find, I need to find my x-intercepts. So I'm going to find my x-intercepts. So I'm going to take my function and I'm going to set it equal to 0. It's already factored for me, so I get x is 0, which I already knew. And if I set this one equal to 0, I could square both sides. I get x equals 2 is going to be the value over here. So my bounds are from 0 to 2. So this is what I'm going to need to integrate. Now this integration problem looks difficult. It's going to require a u substitution. So when I do my u substitution, I need to pick a value for u that when I take the derivative, I see the derivative somewhere. I'm going to pick the innermost function, 4 minus x squared. And when I take the derivative, I get du is negative 2x dx. Now my goal of u substitution is to rewrite the integral and to only use the letter u. I can no longer use the letter x. Well, I can replace this square root with just the square root of u. So that's been replaced. But I still have 6x dx that I need to replace. This does not say 6x dx. But if I multiply this by negative 3, if I multiply both sides by negative 3, I do get 6x dx. So 6x dx, which is the stuff that was left, can be replaced with negative 3 du. Now, I hope you're thinking to yourself, Mr. President did not put bounds on because we need new bounds. These bounds up here only work for x. So I need new bounds. My old lower bound was x equals 0. My new lower bound is going to be u equals, and I'm going to go into this function of u, 4 minus 0, or 4. So my new lower bound is the number 4. My old upper bound was 2. If I need to see what u is, 4 minus 2 squared is 0. So my new upper bound is 0. Now, I'm a little short on space here. So I'm going to transfer this over to here so that I can integrate it a little bit better with more space. So when I transfer it, one thing I'm going to note is that I really don't like that the smaller bound is on the top. So I'm allowed to switch places with those as long as I make my problem negative or make it positive. I basically need to negate it. So I'm going to change it to positive 3. I can pull that out. From 0 to 4, u to the 1/2 du. That's my integration problem. So now I'm going to take my antiderivative, and I get 3u to the 3/2. Instead of divided by 3/2, I'm going to multiply by 2/3. Put these bounds on the end. I'm going to plug, I can cross the 3's out. I'm going to plug my top bound in. So 2 times 4 to the 3/2 minus 2 times 0 to the 3/2. And I'm not going to dare simplify my answer at all. That's what it's going to be. Okay, if you did simplify it, the number that it turns into is 16. But I think that that would have been worth 4 points. If you're grading yourself, I would give yourself 1 point for finding your bounds, 1 point for setting up your integration here, 1 point for rewriting it as u, and a 4th point for your answer. Okay, part B might have stumped a lot of people. Part B says, it is known that for this function, it's the same function we're given before, the derivative is given here. And it says, for a particular spinning toy, the radius of the largest cross-sectional circular slice is 1.2. So what we have going on is we have a cross-sectional circular slice. And we know that the largest radius right here, the top point, is 1.2. That's what they're telling us. And they're asking us, what is the value of C for that particular spinning toy? Well, one thing I want us to make note of, and I'm going to do this down at the bottom, I'll do part B right here, is that since they told us that the largest radius is 1.2, I can think of it that the radius of the largest slice occurs at the maximum. I'm going to write that down. The radius of the largest slice occurs at the maximum. Well, how do we find a maximum? We take the derivative and set it equal to 0. So for a maximum, we're supposed to set our derivative equal to 0. Well, if you look at part B, they gave us a derivative. They said this is my derivative. And if I set that derivative equal to 0, I can basically take my numerator to 0. And if I divide out a c, c is a constant, so the c can just go away. If I divide out a c, it's a constant. Keep solving. And I get x equals the square root of 2. Now, that's not really what they asked us. What they asked us to do was find the value of c. So at this point, we need to go into this equation, which says y equals, I'm just recopying it. And I'm going to start plugging in values that I know. I know 1.2 is my y value. That was my highest point. So 1.2, I don't know c, I'm looking for it. X is the square root of 2. X again is the square root of 2. And I'm just going to solve this right here for c. Looks ugly, but it'll get a little bit nicer as we go. 1.2 equals c root 2. Here I know that the square root of 2 squared is just 2. So 4 minus 2 under the radical is 2. So that's what I have right now. Then if I multiply these square roots together, I just get 2c. And then if I divide both sides by 2, I get my c value of 1.2 divided by 2, and I've answered the question. That was pretty difficult. I would guess that right there was worth 2 points for part B would be my guess. Oops. I would guess this is worth 2 points, that you would get a point for setting your derivative to 0 and get a point for solving for C. And then we still have part C. So part C says, for another spinning toy, the volume is 2 pi. What is the value of C? So this is a spinning toy. I'm going to go back up to the picture for a moment. And this is a revolving solid. Remember, this is a toy that's just spinning and spinning and spinning. And we know that we know what the volume is. Well, to find the volume of a revolving solid, we use the formula pi integrate r squared. That's how we find the volume of a revolving solid. Now, this solid's bounds go from 0 to 2. We had determined that in the beginning. And right here, we're supposed to be putting the radius of this solid. So let's come back up here. And my radius, I know at this point I have it labeled at 1.2, but the radius is different depending on where I'm at. So the radius is just going to be whatever my function is, back down to 0. So my function is this big long thing. I'm going to put that in here. Cx square root of 4 minus x squared. And I know that all this should be 2 pi. So I've got some work to do. So I'm going to say volume is 2 pi. I'm going to recommend simplifying here before integrating. If I square everything, because I need to square everything, the c, the x, everything, this becomes c squared, x squared. Here, if I square the square root, I get, it crosses off, I just get 4 minus x squared. Now, because I'm trying to solve this, this is an equation I'm trying to solve, I could at this point divide each side out by pi. Pi's gone. I can also do this. 2 equals, I can take that constant out front. Integral from 0 to 2. I'm going to distribute this x squared so that I can integrate. So 4x squared minus x to the 4th dx. And now I know how to take the antiderivative of this. I don't need to use u sub or anything. So 2 equals c squared. Taking the antiderivative of each of these terms. The first term becomes 4x cubed over 3 minus the next one's x to the 5th over 5 from 0 to 2. And I need to plug in. If I plug 2 in, I get 2 cubed is 8 times 4 is 32 over 3 minus, I'm going to plug 2 in here. 2 to the 5th is 35 over 3. Nope, sorry, 35 over 5. And then if I plugged 0 in, I would get minus 0, but I don't need to put that here. All right, now, if you're comfortable adding those fractions together, go ahead and do it. But we don't want to make a mistake doing that. So what I would recommend doing is just dividing each side by this ugly mess here. So I'm going to do it over here. I'm going to say 2 divided by this stuff, 32 over 3 minus 35 over 5 equals c squared. And then I'm going to take the square root. Normally when we take the square root, we're going to take plus or minus. This time, we're not going to use plus or minus because they told us up top that c was a positive constant. And that's how I would leave my answer. Okay. I would guess that this was 3 points. And I would guess that you would get 1 point for this integrand here. 1 point for correctly finding the antiderivative. And then the third final point for your answer. That was a pretty tough one, so you should be proud of yourself if you got any points along the way based on how